Okay, so I've given you a little revision test of alkanes and alkenes, which is what we've covered thus far. Okay, so remember, alkanes are substances that are hydrocarbons. They've only got hydrogen and carbon in them, and they only have single bonds between the carbons. Okay, those are alkanes. Alkenes have at least one double bond in the carbon chain, right? And they are also hydrocarbons. So this is up to where we've got. Okay, so let's look at these. So just to refresh our memory, we must remember the prefixes, right? We look at the prefixes. We've got meth is one carbon. Eth is two carbons. Meth, eth, prop is 3 carbons. But is 4 carbons. Pent is 5 carbons. Hex is 6 carbons. Right, these are the prefixes. We've got hex, hept is 7 carbons. Then we've got oct, which is 8. We've got non, which is 9. And we've got dec, which is 10. Okay, now I have given you octane. Octane. So if we look at octane, okay, I'm going to write it. So number one is octane. And I'm purposely using the different colors. So the oct is the prefix. The oct is telling us that there are going to be 8 carbons in the backbone. Okay. The ANE tells us that the carbon backbone is going to be made up of carbon, single bond carbon bonds. Okay. So what we're going to do now is we're going to draw it. So we go, okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8. I purposefully don't make it linear. It can be linear. It doesn't have to be. Right, and then each carbon must have 4 bonds. Each carbon must have 4 bonds. So going around each carbon, you use my circle test. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. Okay. And now we fill up with hydrogens. Okay. So we just put all the hydrogens in. Okay, so that was octane. Okay, that would be 2 marks in an exam. Boom, boom. Okay. Now, what I didn't ask for is I didn't ask for the molecular formula, and I didn't ask for the condensed structural formula. But I'm going to now do it in any case. So if we look at the carbons, we have 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. How many hydrogens do we have?
18.
Well, you can count them, but I want to show you a trick. Can you see that on the ends, the carbons of the ends have got three hydrogens, and the carbons in the middle have got 2 hydrogens. So if we take the hydrogens, one of the hydrogens off on the end, each carbon, 1, 2, 3, 4, 5, 6, 7, 8, each carbon has 2. So I could say, well, okay, the hydrogens is 2 times 8, because each of the carbons has at least 2 hydrogens. And then we must pop the hydrogens at the end on, and so we add 2. So that's going to be C8H18. Now, the reason why I've done it like that is because the general molecular formula for alkanes is given as follows. CnH 2 times N, which is the number of carbons, plus the 2 hydrogens, the hydrogen on each end. That is the general molecular formula for alkanes. I'm going to say it again. This is the general molecular formula. This is the general molecular formula, MF, for alkanes. Okay. This is important to know because this does get asked at times. Okay. Let's look at the condensed structural formula. So the condensed structural formula, I'm going to start on the left-hand side. I'm going to say, okay, that is CH3. So what I've done is I have started there. But now what I want to show you is, can you see there's 1, 2, 3, 4, 5, 6 of the same thing? Can you see there's 6 of the same thing? I just want to stay in the recording. All right. So what I'm going to do, because the whole idea of condensed structural formula is a shorthand notation, I'm going to do the following. I'm going to say, okay, this is CH, and how many of those CH2, CH2? So each of these are CH2, 1, 2, 3, 4, 5, 6. 6. So the CH2 is repeated 6 times. And then at the end, we must end with CH3. So that is CH3. So this is the condensed structural formulae of this compound. Can you write it out as CH3, CH2, 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 6 times CH3? Yes, but this is the shortened, most abbreviated form of the condensed structural formula. Are we okay with that? Cool. Let's move to the next one. All right, so the next one was oct2ene. Oct2ene. So let's go there. Number 2 was oct, and it was 2-ene. So the oct obviously tells us that there's 8 carbons. The 2-ene tells us that there's 1 double bond between carbon 2 and carbon 3. That 2 there is the descriptor of where the double bond sits in the backbone between carbon 2 and carbon 3. So I'm going to go quickly here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Always count your carbons again. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. Doesn't matter if I put that single bond top and bottom. 1, 2, 3, 4, or 1, 2, 3, 4, doesn't matter. All right, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we fill up with hydrogens. All right, so we go hydrogens. Okay, so that would be the structural formulae for oct2ene. All right, so now let's just look at the molecular formula. The molecular formula is C8. How many hydrogens? Can you see that by adding the double bond, we've lost 2 hydrogens? So this is going to be H16. In its general form, the general molecular formula for alkenes, but now only alkenes with a single double bond, not double dienes and trienes, for just a simple alkene with a single double bond is going to be CnH2n. That is the general molecular formula for alkenes. Okay? If we look now at the condensed structural formula, starting on the left-hand side, it's going to be CH3. It's going to be CH. So CH3CH, CH. Okay, now, this is where we can get tricky. Do you see these two CHs there? I could say CH2. Now, if you are given this, it starts to become difficult to really immediately interpret what kind of compound you're dealing with, unless you've got a lot of experience. My advice is, if you're given this, like you will see in exam type questions, you then expand it to structural formulae before you answer. So then what have we got here? How many of these CH2s do we have? 1, 2, 3, 4. All right, so we're going to have CH2. We're going to have 4 of them, and then we're going to end off with CH3. All right, now in your exam, I've already moderated it. All right, these kind of questions are in your exam. Okay, where you're asked to draw the structural formulae or provide the condensed structural formulae of certain alkanes and alkenes. Right. Are there any questions on this at this stage?
So that's the condensed structure.
This is the condensed structural formula. Now I've got a question for you. Is this a saturated or unsaturated hydrocarbon? This is unsaturated. Because it doesn't have because of the double bond, because it doesn't have the maximum amount of hydrogens that could possibly be found around 8 carbons. So this is an unsaturated hydrocarbon. As soon as you've got double or triple bonds in a hydrocarbon, it's unsaturated. So the only saturated hydrocarbons are alkanes. Okay, I am not going to do number 3, because all that number 3 is number 2, where the double bond sits there now. Okay. Can you recall what we would call oct2-ene and oct3-ene? We would say they are, okay, not you, Declan, yet. They're not dienes. Good try. Remember, in science, it's cool to be wrong, because it means you're trying. I mean, if you try and you get it wrong, it's cool. It's okay. Science is all about that. Okay, Josh? They are isomers. Isos in Greek means equal, so they have the same molecular formula, but they have a different structural formula. But there's a specific type of isomer. Can you recall what the isomer type is? They are positional isomers, because of the fact that it's the position of the double bond varies. Very good. Very good. Absolutely. Absolutely. You also get functional isomers as well, which we will get to at a later stage. Right, let's look at hepta 1,3 diene. Hepta 1,3 diene. Right, so if we look at number 4, hepta, and we said this is 1,3 diene. So this is going to be 1,3 diene. The hepta tells us how many carbons? 7. The ene tells us we've got double bonds between the carbons, and the di tells us that we've got how many? 2 times that. And the 1 and the 3 gives us the position. Right, so let's start off. We've got 7 carbons, 1, 2, 3, 4, 5, 6, 7. The double bonds occur between carbon 1 and 2, and between carbon 3 and 4. So we always use the lowest number of the adjacent carbons to describe where the double bond is. The rest are going to be single bonds. And then we use the circle test. Around each carbon, 1, 2, 3, 4. Remember, you can put the lines vertical, but generally we put it like that just to take into account that all of these bonds are negative, so they're going to try and move as far away from each other as possible. 1, 2, 3, 4. 1, 2, 3, 4. Doesn't matter where we put. Okay. When you go to university, you'll start to work with things called cis and trans isomers, where it's to do with where in double and triple bonds, where not all the bonds can rotate, you get different symmetries, depending upon where that hydrogen sits. Anyway, that's not for us on high school level. All right, 1, 2, 3, 4. Just count, always be careful. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It's very easy to make a mistake there. The rest are easy. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Now, let's fill up with hydrogens. Right. Okay. Are we okay with this? Are you guys okay? All right. I just want to check how much time we still have in this lesson. Okay. Just want to see. This ends in 18 minutes time. Okay. That's fine. Not a problem. All right. That gives me more than enough time to do what I need to do.
Can you explain how like the 1, 2, 3, 4 thing works? I understand like the double bar lines and that sort of stuff.
Okay, no problem. So the diene, like bicycle, di means bi and di mean two. The ene is telling us it's a double bond. Okay. Now, obviously, in a compound with 7 carbons, you have quite a few options as to where you could put 2 double bonds. You could put 2 double bonds there, you could put 2 double bonds there, you could put 1 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 there. You agree? All right. So you need to have a descriptor. You need to have a method in order to explain or describe where the double bonds are positioned in that carbon. So we use a lowest number method. So the 1 double bond is going to occur at carbon number 1. Now, carbon number 1 is one of the carbons at the end. I could start there, 1, 2, 3, 4, 5, 6, 7, or there, 1, 2, 3, 4, 5, 6, 7. If I started there, the double bond would be there. It doesn't really make a difference because these molecules are rotating and moving around all the time in reality. Okay, so we say, okay, if I now commit to this thing, carbon number 1, then the first double bond is between carbon 1 and 2. So that 1, it's a bit like DNA. If you have an A, then you know there's a T on the other side. If you have a G, you know there's a C on the other side, okay? So if you have a 1 here, you know there's a 2 in that description as well. It's between 1 and 2. If you have a 3 there, it's telling you it's between 3 and 4. Are you okay with that?
Yeah, I got it.
Okay, it does take practice, okay? And the nice thing about this section is there's a very clear, definite system, and we continue to review. All right, so, okay, so if we looked at the condensed structural formula here, and I'm going to go quickly, the condensed structural formula here would equal CH2, we've got 1, we've got CH, and we've got CH, and we've got CH. So we actually have 3 CHHs. Just check again. Always be careful. Less haste, more speed. Can you see we've got CH 1, 2, 3 times. So we put the subscript there. Apologies for that. And then we've got 2 CH2s that are sitting inside the molecule. So we've got CH2, and then last but not least is what's on the end, CH3.
CH2 inside the brackets.
Sorry, I can't hear you.
CH2 inside the brackets as well.
CH2.
The second set of CH2.
Second law.
CH2.
Oh, thank you, Taylor. You spot on. Can you see it's not, you're absolutely right. Thank you very much, young lady. There we go. Spot on. Thank you. Thank you. Thank you. Thank you. I was a bit slow on that. Okay. This is CH2, not CH. Okay. It's easy to make mistakes, so it's better to go slower, all right, and do it properly. So it's CH2, CH3. Thank you very much. What is the molecular formula? We've got C7. Is this going to be H14? Why not? Because there's two double bonds. So this is actually going to be H12. Every time you add a double bond, you lose two hydrogens. Okay? So what have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Are there any questions? Josh?
This one had the general formula.
This would not be the general formula.
Does it have one?
Not in our syllabus. We don't work with it in our syllabus. I assume that yes, you can set up a molecular, a general formula, but I don't think it's as neat and as nice as the one for just a single double bond. All right. Okay. Now, ladies and gentlemen, what is our goal? What is our goal today? Right. Now, my goal, I have a very ambitious goal. My goal is I want you to learn how to swear in IUPAC. I'll say it. I want you to learn how to swear in IUPAC. Okay. I see Carl, was he looking at Liam and going like, what on earth is Mr. D about? Let me explain. By the time we have named this, when you say it, it's going to sound like you're swearing, okay? It's weird. The naming in IUPAC can produce very, very weird names for compounds. Okay, so let's start off. I referred to this in the last lesson, but you really need to focus now because I'm actually going to go quite quickly. All right, so if you look here, can you see that fluorine has substituted a hydrogen that would have been there normally? Do you agree with that? So the fluorine is a substituent. When we do chemical reactions, guess what? Drum roll. We will use substitution reactions for that. Okay. Can you see the chlorine has substituted a hydrogen that was originally there? Okay. Can you see that here an iodine, a fluorine, and a bromine have substituted hydrogens that were there? Now, what is common about fluorine, chlorine, bromine, and iodine? They are halogens. So does anyone want to venture a guess what you would call an alkane that has halogen substituents? Give it a go. Give it a go. Remember, in my class, you can always give it a try. What about a halogen alkane? Well, it doesn't sound good. How about a haloalkane? When I talk about halo, I'm not talking about Navy SEALs now jumping out of airplanes, high altitude. I don't know what the LO stands for. All right, we're talking about alkanes that have their hydrogens or some of their hydrogens substituted with halogens. So when we work with a substance like this, this would be a halo, Sophia, haloalkene, because it's got a double bond. All right. So this would be a haloalkene. But there's another name for it, which they also use in the syllabus, and they call them alkyl halides. Alkyl halides. They both mean the same thing, and they are both accepted. So when next week we formalize what our homologous series is, it's a family of organic compounds. The homogeneous, the homologous series for these compounds would be haloalkanes, haloalkene in this case, or alkyl halides. Okay, now, ladies and gentlemen, when we are dealing with substituents that are alkanes, so when we are dealing with substituents that are alkanes, let me go to this slide. Okay, substituents that are alkanes. I've now stopped spelling. Substituents that are alkanes, then we use the following, here's a new term, nomenclature. Okay, so the word nomenclature is a fancy word that scientists use to impress people, which basically means terminology. So the nomenclature, we're dealing with the IUPAC nomenclature. So we would say, if we're dealing with an F, this we would use the nomenclature fluoro. Cl chlorine will be chloro. Bromine will be bromo. And wait for it, iodine, sounds like something from Star Wars, iodo. Okay, iodo. Yodo and iodo. Are you a Trekkie or are you a Star Wars fan? Who's a Trekkie in this class? Who likes Star Trek? Who likes Star Wars? Oh my word, what a boring class. This is a science class. It should be filled with nerds. It doesn't look like it is. Declan, you and I are nerds here. Nerds rule. Okay, cool. Now, so if we go back now, right, pay rapt attention, because I'm going to give you a nice homework exercise for the weekend. All right, so going back here, what I would like you to do is to do the following with me. The double bond dictates the numbering. The double bond dictates the numbering. You choose the numbering that's going to give you the lowest descriptor for the double bond. So going from this side, 1, 2, 3, 4, 5. Okay, if you see that, that's 5 is pent. Right? And it's ene, because there's a double bond. So this is the carbon backbone. This is the carbon backbone. So we start with that. That's the carbon backbone. 1, 2, 3, 4, 5. Pent, and there's an ene. If I had started on that side, 1, 2, 3, 4, 5, this double bond would be 3, 4, and not 2, 3. Let me just show. I'm going to describe this 1, 2, 3. This is going to be pent 2 ene. Okay. If I had started there, 1, 2, 3, 4, it would have been pent 3 ene. So we choose the numbering based on the lowest descriptor, lowest number descriptor, or lowest value descriptor for the double bond. The backbones, double bond or triple bond rings. Okay? Cool. Now, if we now go and we look and we say, okay, what else do we have here? Well, now we see, wait a minute, we have got, if I start here, I have got 1 fluoro, 1 bromo, 1 iodo, 4 chloro, and I've got 4 fluoro. Okay, let's just see here. We've got 1 fluoro, 1 bromo, 1 iodo, 4 chloro, 4 fluoro. All right. Now, can you see you've got 2 fluoros there? So what we're going to do is we're going to say, okay, so this is 1,4 difluoro. Can you see you've got on 1 and on 4, you've got fluorine. So it's 1,4 difluoro. Okay. Then When we lay this name out, we are going to not take the D, the di, or the tri in there. Okay, we're going to work with, in alphabetical order, we're going to put them in alphabetical order based on fluoro, chloro, iodo, bromo. Okay, we're going to get to that. Now, can you see on this side here, all right, we have what's called an alkyl group. Okay, now alkyl groups are like alkanes, but they are now substituents. So when your alkyl branch has got one carbon, this will be methyl. That is for one carbon. If you've got two carbons, it's going to be ethyl or ethyl, and we won't go further than propyl. Okay, so in this case, we have methyl. So we have got 2-methyl. 2-methyl. All right, and the M also counts when it comes to alphabetical. Okay, so the backbone goes right at the end. Okay, we're going to practice this a lot. Okay, but what I've done here is I've introduced two new concepts, and I'm well aware of the fact that I haven't done alkynes, because the alkynes are going to just pop in very quickly, because alkynes are just triple bonds. Okay, so looking here, how would we write this out? Well, what would be the first alphabetically? It would be bromo, eh? So this is going to be 1 bromo. The next would be 4 chloro. Note that I put a hyphen between 1 bromo and 4 chloro. Right, what would be the next? Okay, we have the fluoros out, would be fluoro, eh? Correct, so it will be 1,4 difluoro. Then it's going to be 1 iodo. The methyl is the M comes after the I, so that's going to be 2-methyl. And then last but not least, all right, now people debate about this, whether you should leave a space or not. Okay, I generally don't leave a space. I put the backbone in right there. I go pent 2 in. Okay, so let's now swear in IUPAC. What is the name of this compound? 1 bromo, 4 chloro, 1,4 difluoro, 1 iodo, 2-methyl, pent 2 in. Bang! Welcome to nomenclature in organic chemistry. Now, ladies and gentlemen, in the last few minutes, I just want to add one more thing. And then I'm going to give you a smorgasbord of exercises to do. When it comes to alkynes, alkynes equal hydrocarbons with at least 1 carbon triple bond. So if I take, for instance, this compound, what would we call this compound? Josh, what do you think we would call this compound? How many carbons does it have? So we would start with F. Agreed? The alkynes, the subscript, unlike ANE or ENE, this is YNE. So this would be ethyne, commonly known as acetylene. Oxyacetylene, you know, in the movies, you see the guys trying to crack into a safe, and then they've got this burner, and then they light it, and then you get this flame that they use to cut through the metal. That's called an oxyacetylene torch. The acetylene is ethyne. All right. What would propyne be? If we said, okay, propyne, this would be 1, 2, 3, meth, eth, prop. The triple bond would be on one of them. Doesn't matter which one. It will be between 1 and 2. And now you go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then you pop the hydrogens in. No, no hydrogens there. So now, there's quite a bit we've done. I will post the homework, all right, on Classroom, which I want you to do, which will basically cover all that we've done thus far. Yes, Josh?
So the only carbon that has 4 atoms.
I'll be with you now.